Here comes Jeef Noon. Jeef, Jeeef. Amazon Alexa does a lot of good things, but she just messed up she butchered my name. Butchered it on this happy Friday. Hey everybody. Thanks for joining. So today's office, so if you've been on the stream before, this is episode 26, I think. So we're a quarter of the way to the century mark. We have to have a party when we hit 100 streams. So today's, as you can see, hopefully it's streaming okay. It looks a little jittery. Hope you guys can see it okay. Anyway, we start off with a GIF from The Office every week. This one is a special one because this is Michael Scott holding Jan's baby in the air. And the reason we're doing this is because a good friend of the show, Ice Cream Codes, had a baby last night. So let's do something, Twitch, let's do this. Let's go wish him and the missus, twitch.tv. I think it's Ice Cream Codes. Hey all, welcome Trinity. Here's Ice Cream's channel. So I think can we whisper to him here? Toe Jam and Earl. Let's see, how can we leave Ice Cream a message? Can we just send one here? So if everyone watching at some point can go to Ice Cream Codes, go to this link and go here, boom, and just tell him congrats or something. All right, congrats on the baby, and best wishes. Well, let's give him a little, can we give him a little icon? How do we give emojis? We can't. Let's see if that works. Oh, we gotta be logged in. That's all right, I can do it this way. Drag this over. Let's see here. So now I'm logged in as me, and let's try it again. Congrats on the baby. Hope all is well. Oh, he's on! What's up, Ice Cream? Well, congrats. We were going to leave you some surprises, but anyway, hope you and the family are doing well. Alright, and I hope you get these messages. I don't know if this will work or not. I think you can, maybe if we're logged in we can whisper, right? If I right click? Nope. Alright, doesn't matter. So, today's episode, let's talk about that. Today, we're going to use another type of object detection. So, if you've been on the stream before, we've used Gluon CV to detect objects. We used Facebook, what was the Facebook library called? Detectron? Facebook Detectron. The new baby is here. Stay healthy. New baby Andy's here. Okay. Yeah, Detectron was a cool one. If you remember that one, we took an image of a man wearing a backpack that had a Google Maps camera on top of it, like a big 360 camera. And we used Detectron to detect the pieces of that. We've used MXNet. And object detection is really important in computer vision and robotics for a lot of reasons. Sometimes you'll want to identify an object and go to it. Sometimes you'll want to avoid it, like a pedestrian, unless you're Trinity. The Trinity, when we do our autonomous driving streams, does not obey the laws of mankind and looks for pedestrians. Ice Cream says, still in the hospital waiting the full 24 hours before being released, just listening in. All right, cool. Ice Cream joined me for a little bit, so I did some prep work for the stream today. He joined earlier this week, so he's seen some of this. Some of it will be brand new for all of us. But so we've done object detection with those things. Now we're going to do it one more way, and that is with color. So imagine color detection, being able to detect a color and then either go towards the color, avoid it, or do something in response. So today what I thought we'd do, I've been playing this game. I think you know the game. YouTube, we're going to go to Doom Eternal. Alright, let's see. I actually thought I had one pulled up here. Oh, maybe I didn't. YouTube, Doom Eternal gameplay. So I've been playing a lot of this, and I thought, it'd be really cool if we could detect events happening in this game. And the event in particular that I want to detect is when I'm hit. So when you get hit by one of these aliens, I'd like to be able to provide some kind of feedback. And I got this idea from an interview I saw with John Carmack. John is a co-founder of id Software and one of the creators of Doom. And he told this story on a podcast one time about how way back, I think it was early 90s, a guy came in and had basically hacked the original Doom to get events like this and get feedback, and then built a vest. I think he built a vest that gave feedback. So imagine getting punched in the chest by something, even if it's some kind of electrical pop, when you get hit. So I thought that'd be fun to try. So let me show you what we'll do here. if this will play. Maybe it won't want to. We'll make it play. Being a little slow. We could do it with real Doom. I have Doom loaded, but I'm not set up to play such a graphic-intensive game and stream at the same time. So we'll just do it with a video, but it'll give you the idea, and then you can go and take your own. You can take this code. I'll share the code with you if you want, and you can take it and build it into something else. Don't know why Doom's not playing, though. Let's try this again. Alright. I'm going to mute it. This is Doom if you haven't seen it. It is a first-person shooter, so it can be a little violent. The good thing is you're not killing humans, you're killing evil aliens. So, this is some in-action gameplay. We're going to skip it because we don't really care about feedback from this. I know around the 9-minute mark, there's some good action where there's actually... Alright, here we go. So let's watch this. So my first thought was, when we get hit, how do we know if we get hit? Let's jump ahead just a little bit. Here we go. So here comes an alien that he's going to fight. Right here. So let's take note here. We're shooting. We haven't been hit yet. There's a couple things we can do. So on the lower left, we can see some shield power. We can see our health at 125. We could isolate this screen. So if you're playing the game, if we're coding against the game, we can build something to isolate this part of the screen here where it says 125. And we can look for that meter to shrink. I've done that before on Galaga. So I taught AI to play Galaga. And the way I knew, we use reinforcement learning, the way I knew to, if there was a negative reward, is if there was a hit icon that happened, or a health icon that lost, or a score icon. I looked at the score to know that it did well by hitting a ship. So you can see what happens when we get hit. Let's watch this real slow. We're going to go playback speed. Let's go a quarter. So watch this laser come in, these missiles. Right there. There's one hit. See this red right here? And then notice these corners. You get red around the corners. Your whole edge gets red, indicating you've been hit. So here's what we need to do. We need to isolate the red. If we can isolate the red, we'll look at this whole frame. We can see what the percentage of red is, and then we'll know if it exceeds a certain percent, then we've been hit. So that's one tactic. The other tactic is just to isolate a piece of it, which would be a much more efficient way to do it. So what I've done is created a script that I'll show you now, where I just isolate a 50 by 50 or 150 by 150 corner of this screen. So we're going to do that now. So this is a script, and we'll go through it and we'll watch it in action. So first of all, we have to create a region of interest. So we're looking at, let's just give us some room here, pull this one over here. There we go. Let's pause right here. It's probably pretty good. It's got red on it. Okay. So we need a bounding box. So I start at the top. So we just identify the top pixel and the left pixel. So I come down 150 and I come over 20, which is roughly in here. And then I grab a 50 by 50 region of interest. I just want to pay attention to this region. So here again, we're hit. If we play a little bit back, we can see we're not hit yet. So there won't be any red here. So the way we detect colors is using HSV colors. There's a color range, hue, saturation, and value. So if you look at a typical RGB, well, you know what RGB looks like. Let's look at HSV color wheel. Probably is a good way to think about it. It requires a different way to think about colors. Instead of typical RGB, think of it as this big cake. And we have a hue and saturation and the value from very dark to very light. So we want to cover this range of red from very dark to very light. There's different ways to do it. The best way I found to do it for this is I found a script that we're going to look at now called Color Picker. And we'll run Color Picker. Let me see if I save this. Yeah, Color Filter HSV. Let's go to the terminal, and I'll show you how I got this range. So here's the fun thing that we're going to do at the end too. We're going to take, we're going to take this, here we go, this Raspberry Pi. Sorry, it's not a Raspberry Pi, it's a Mindstorm EV3. We're going to take the Mindstorm EV3, and what I've built is a nice motor with blades attached. So what I want to do is every time we get hit, I want to, oh hey, W. Giorgio, welcome. Yeah, W. Giorgio actually helped me. He helped me find this HSV trick. So big props to W. Giorgio. Thanks for joining today too. So what we'll do is we're going to plug this into the Mindstorm. Whenever we get hit, I want this thing to fire off and punish me basically for getting hit, for not being a good Doom player. So that's it. We're going to get to that in a second. In fact, what I'll do now is turn this Mindstorm on. Give it a chance to boot up. Mindstorms are a really good way to get into robotics, by the way. If you get a chance to grab one, and I'll show you a few things today that'll make it pretty easy. So Trinity says it's going to hit you every time it gets hit in the game. Exactly. But we need to tell it when we're hit. And the only way we can do that is to determine if we see red up here in this area. Alright, so can you see enough of the screen? I'm going to go ahead and turn off. We'll just go to coding view for a little bit. Okay, so let's go to D. Let's go to, what do we call it? I call this Doom Eternal or Doom Feedback. Color picker. So let's do Python color picker.py. Filter is HSV. And we're going to say an image. I've got some images here. We're going to do Doom full hit.png. Oops, let's do Conda. Oh, I've got a Conda environment created for this. Let me get that. D, CD, Doom. Whoops, not like that. CD. Hey, Justin, welcome. Local rock star Just Jeffress joining our stream. So the image we're going to call, we'll say Doom full.png. I've created a couple of screenshots that we can use. Ooh, that looks bad, doesn't it? Oh, I know. There's one more little. Let's get Q there. There's one more little switch we need to add. Preview -P. We need this -P. All right, cool. So here's a scene in Doom, and you can see some red here. But this red wouldn't really indicate a hit. And we're only looking at this region of interest anyway, so let's get a different one. Let's try Doom full hit. I think this is a picture. Yeah, this is a picture where I've gotten hit. So what I'm doing right now with this tool, this HSV tool, will let me isolate the red. I want this red in this corner here. And so I can move these sliders around until I find it. So we know that's not going to be the right one yet. Basically, I want to get rid of everything that's not red as much as I can. That's pretty close. Let's get rid of this. Nope, too much. Too much. Way too much. Let's bring this back to 255. See, when I do this VMAX, see how this red line here, one of the health line, or it's actually YouTube's red line, but that's okay. I still would want that. So we'll keep that. I still have a little bit too much yellow and blue. I'm going to try to get rid of that with this slider. Nope. There are other ways to do this, but this is what I found to be the easiest so far. We're going to go with that. So when you're filtering with OpenCV will filter, and I'll show you this. All right. So you create these HSV lowers and uppers. So here is our lower, the mins. So I found that 0, 138, and 96 worked really well. So let's move this. 96, close enough. 138, it's close enough. These sliders aren't very precise. Then the upper I found, well, I've used 255, 255, 255. You can see it does pretty well. So what we'll do is we'll create a mask, and that's what we want to see. We only want to see the red. Then we're going to count the number of red pixels, or number of pixels that actually are shown that are not black. If it's above 5,000, this is a number I found through trial and error. If it's above 5,000, then I'll know that there were a lot of red pixels in my little region of interest, and that is probably a hit. Now, I did run into a couple of problems with some different images. So here's an image. Let's see if I can get this multiple. Sometimes I was able to isolate red, but it still picked up a lot of blue. But finally, I used this image here. Let me just load this one and show you. This one really helped me get everything tuned in. The name of this image is what again? Doom multiple scenes. Giorgio, screwed. Hopefully, yes. Hopefully it's a different red. This one helped me get past it. Doom multiple scenes. I may not have found that one. Doom multiple SCENES. What did I misspell that? Doom multiple scenes. Well, that's okay. Let me show you what the script does in action now. So let's run the script. Move it over here to give our YouTube some space. Whoops. And we want that there. Okay, here we go. So let's run the script. All right, so what we're doing, we're seeing a preview of what it sees now. So again, we don't want to see, we want to see a lot of black unless we're getting hit. So let's play this for a little bit and see what happens. There's some hit. See that? So we saw red here. And again, remember, we're looking at this top right corner. 50 by 50 is actually really small. It's probably about from where you see the crosshairs to the corner. That's all it's looking at. If it sees red there, then we're getting a hit. So lots of hits, lots of hits, lots of hits still. You can see on our left side that we're still being damaged. So ideally, this thing will be spinning and hurting us because we're damaged. There's another one. If I jump ahead a little bit to a calmer scene, maybe a less gruesome scene. There we go. That's not less gruesome. Let's go back a little bit. Yeah, so there's no, if it jumps back here, you'll see, but there's no damage. Well, there's damage there. That would be one issue if we're in a scene with lots of red where maybe there's lava in the background like this. But you can see here we're not getting hit, and there's a lot of black pixels, which is great. Okay, let's get to the fun stuff. So first of all, if we get a hit, so it analyzes the image, and it says if the number of red pixels is above the minimum hit threshold, return true. Let's go back down to analyze image right here. If is hit, and I have a little output that says activate all the haptics. And I'll let you see that output. Let's see. I don't know why we didn't see it there, actually. We should have been seeing activate all the haptics. All right, let's see if we see some hits here. And I've got a little delay set up on it too. I don't want it to buzz the whole time. Like if we get hit here once, that might be part of the code issue. If we get here once, I don't want that thing spinning nonstop. But let's just get rid of that for now. Let's try this. Now this send haptic signal does nothing yet. This is what we're going to code today. Let's look at the number of red pixels. We may need to lower that threshold. There we go. Okay, so this one has 3,780. That's how many red pixels it found. Trinity, it should whack you nonstop if you're doing poorly. It really should. Maybe it's a really good way to train. It's like reinforcement learning for humans. So 3780, and I was looking for 5,000. So that's why we're not getting any. Let's do this. If it's above, if there are 3,000 little pixels there, which. So you might be wondering, we have a 50 by 50 frame. How can there be 3,000 pixels? It should be 250 pixels. Don't forget there are 3 channels there too: a red, green, and blue, or an HS and a V actually. Really, it's looking for red, green, and blue. All right, let's run this again. You can see a lot of hits. Activate all the haptics. All right, let's hook up the Mindstorms now. So again, the Mindstorm is this little dude here that you see on the screen. We need to talk to it, and we're going to use sockets to talk to it. So let's write this. Let's see. I don't think we even need to let's see. Python 3 socket communication server client. I don't think I have 3.8, but I don't think it really matters for the sockets probably. Let's see if we can find some good code just to start with. Okay, we're going to do that. So this is Echo server. What is this? Is this server and a client with socket? We're connecting, we're binding, we're listening for a connection, and how do we send? Connection receive, echo client. Okay, good. So we'll have the client on the what's it called? The Mindstorm. Let's blow this up here. See that okay? I'll go ahead and go to coding views just so we can see this for a while. So let's SSH. So if you have the Mindstorm, you can just do SSH robot into EV3 dev. We're going to write this client Password by default is maker, M-A-K-E-R. Alright, so we'll make a directory called Doom Feedback. And let's edit this here. Let's see. Whoops. I'll just call it main. I'm just going to copy most of this code. Import socket. Our host is, I don't know what the host is. I guess it could be 127, but we can just do hostname -I 122. Oh, it should be a 192 address. Let's see. Let me see what this is connected to. I don't want to connect it to my all network connections. Wire. We're going to turn off the wire. We're going to disconnect from the wire. I don't want it to be wireless. That way it'll be on the same connection as this device. So I may have to SSH back into it, but we'll find out. I'm going to keep the Mindstorm close so we can attach the blades to it. All right, let's see. Hostname I. Let's get back into it. .127.0.0.2. I think we can use that. CD Doom feedback. Let me just make sure it connects to, let's see, wireless and networks, Wi-Fi. It'll probably work with 127.0.0.2. Let's just do it. Nano main. Okay. So host we'll call 127.0.0.2. Maybe we need these ticks around it. Port. That's weird. We don't need that. We'll just do 5005. With socket. So we're going to connect to the host. So the host is that. Send all data receive. Okay, this is here. This is I think we need this one up here. We need server here. Connected, if not data. I don't like this example. I'm trying to do a little too much. I don't think we need that much. We need a really simple one. I've used really simple ones before. That was a little bit too convoluted. Same one. We'll give this another one more try, and then we'll come back to that one. PubNub's a book, right? Yeah, we can't look at that probably, or can we? All right, we'll go back to the original. We'll make it work. There's so much data here. We're just going to copy and paste. That'll be a little easier, a little quicker at least. All right, so we have this. We know our host is... I don't like that either. I think we really do need a host name. Let's try to connect. See if I'm on 2001, or sorry, 127.0.0.1. I'm just going through the network connections on the EV3. Okay, the connection wasn't active, so I think this will do it. It takes a second for it to kick in. Still waiting. We'll let that go. I think we can probably, if we still have a connection here, we can keep working on this. All right, let's get rid of all this. We don't want to send data here. We want to receive data here. So this is what we want. We're going to receive data from our little script that said we were hit in Doom. We can come back. We'll keep that port 65432. Non-privileged ports are greater than 1023. While true. Okay, let's do this too. So when we get a message here, we want to do ev3 dev python. There's some really good examples that will help us spin motors, talk, things like that. So let's look at those. I think they're on GitHub. Okay, here we go. So we want these. So this gives us all of the motors, sensors, LEDs, everything we need for that. Let's bring that up here. Okay, we've got those. And then let's just make it, I know there's a talk somewhere or speak. We're going to do that first. We need sound. We'll just make it say something. What are we going to make what are we going to make Mindstorm say if we get hit? Anyone have any suggestions? So when we get data with connection while true, data if not data break, connection send all connected by. I think we'll just do it right here. We'll say let's do ouch. Don't care about that part yet. All right, let's try that. So we are connected now. We should see a better host name. We still see 169. That's okay. We're gonna go with it. 169.254.2.180. I'm not gonna remember that right now. You suck. Yeah, that's what I should tell you. Play more. All right, so that's that. It's not really a standard loopback. And this could be. Oh, what is that? This could be anything we want really as above. I would really do like let's go 5,000. I don't think anything's listing on that. That's just easier for me to remember when I have the client. So let's just run this and see what happens. It shouldn't do anything. It should just sit here and wait for a connection. Oh, let's do. We need Python 3 to access these. Toasty. That'd be good too. Let's do that. Inconsistent use of tabs and spaces. What did we do wrong? If not, data break. I think I have some weird. Is this line 22? I used tabs. There we go. That was the problem. All right. I think we're gonna have the same problem here. All right. Python gets pretty picky about that. All right. Here we go. That should just listen. Good, so it's listening, and let's do one more window. Let's add, how do we add another terminal here? We can go here. And let's just make a simple file called nanoclient.py. No, we can't nano there, we could just do it here. Make a new file to send a message. We're going to send a simple message. Send.py. Let's go look at this socket programming. Okay. Right here's all we need. Paste. And we know, what was the address? It was 169.2542.180. We're using port 5000. And send hello world. Let's try it. See what happens. I think we have a little issue probably with networking because these are on, let's see, we're tethered to this. Couldn't get it. All right, that makes sense. Let me try the wireless again. So all network connections, Wi-Fi, start scan. It's gonna scan. Let me get this on the Wi-Fi and see if that makes it. If we're on the same, because I think ipconfig, I am on an i6 169 address 2 though. Oh, here we go. 192. Okay, I'm online. There we go. 192.168.86.22. 86.22. Let's change this. 192.168.86.22. Let's run this again. All right, so server's ready. Let's send a message. We should hear what should we hear here? We should just see a message pop up over on this side, on the right side, if we have the ports right. So far, nothing. Let's change this port. Port, I wonder if the port, it shouldn't have to be a string, but we're going to check and make sure it's not. Okay. So let's just change this to 5005. Run that. Let's go back to this code. We'll change this to 5005. Oh, here's the problem. 192.168.86.22. All right, we're going to try this again. So we're listening on one. We're going to fire off a message in the other. There we go. So connected.
Ouch.
Ouch. All right, did we hear it? Let's try it again. Oh, it's got to be running. That's interesting too. We need this thing to run nonstop.
Ouch.
All right, so we have ouch. Let's change it to toasty for W Giorgio. Nano main. All right, so we definitely have that working. So if we get a message, we're going to say toasty, and then we want to spin this. So this is the blade of death. Ouch. This is blade of death. We want to spin this. So we're going to connect it. If you haven't seen how these work, it's pretty simple. It's almost like an old phone or a Cat5 cable. It goes in there, and then there are ports on the back of the Mindstorm. So these are the motor ports, so A, B, C, and D. I'll just pick A. We'll plug it into A. All right, so we have that. I'm gonna set it aside for a little bit. It'll be off camera, but let's get the code to make that spin. And I believe it's right here on this GitHub. I'll paste this here. That doesn't seem nearly threatening enough for you, JB Nunn. It depends on where I hold it. What if I hold it right by my eye? Will that make you feel better, Trinity? I'll just hold it right here. When I get hit in Doom, it'll slice me. How about that? Drive with 2 motors. So single motor. There we go. Copy this code. So when it says, it's going to say toasty, and then we want it to say this. Oops. Let's paste it. We're going to do M large motor output A, and what do you think, Trinity? 75% maximum speed for 5. We want 100%, right? 100%. Carnage. So it should say toasty. It should spin the motor. Let's see if that works. Hold this up. Okay. See this? All right. This is all your fault, Trinity, if this goes south. No, not real damage. Oh, we're going to go real damage. Toasty. All right. We got an error. Large motor is out. A is not connected. A and A. Oh, I bet you there are other motors. There are other motors that are bigger. Maybe we have the wrong motor. So what is this? Mindstorm motor sizes. Let's see if this is small. Medium servo motor. Okay, that's this. So it's a medium servo motor. So So let's go nano. Let's look at this again. Wear goggles. Hey, Gold Zulu, welcome. Let's see. Gold Zulu, were you on the stream? You were on one of my other streams where we started this, I think. What do we say? Medium? Let's just try medium motor. Medium motor. And we'll change this to medium motor. Yeah, I agree. Wear goggles. I had a friend one time. He was grinding some metal and wasn't wearing goggles. And a little piece got him in the eye and blinded him in that eye for life. It's not cool. All right. I do wear goggles when I mow or edge. Been popped a few times and they've saved me. All right, let's try this again. So we're going to get that ready. And welcome back, Gold Zulu. Thank you. And let's do this. We should hear toasty, and this should spin. I'm not going to keep it too close.
Toasty.
Oh, yeah. Okay. That wasn't enough. Yeah, 5 seconds was enough time. Okay, we're really close now. So let's do this. The code on the Mindstorm is right. We just need to add this code right here to our main program that looks for red. So let's see. And we need to keep this guy running a little bit longer too. It shouldn't die after the first hit. So while true, if not data break. Connected. We'll get it working first, and we can worry about that loop. So we're going to import socket here. Let's go up here. We have import numpy, import sys. Socket is kind of like sys. It's like a base package, so I like keeping those together. And then we're going to do our host and our port and our with socket. This is just printing the response we get back. I don't care about that. We're going to keep that out. So now we have send haptic signal. This is where we're going to paste this code. So if we get a hit, it returns true right here, and then it sends haptic signal. We're going to send it right here. We have our host and our port. We can keep that at the top since it's a constant. And we'll move this over. We don't really need hello world. We don't need anything, but we'll just put hit. All we want to do is send a message. Over here on the Mindstorm, we could have logic that says if it sees hit, do this. If it sees, I don't know. If you're empty, if your gun is empty or you're jumping, maybe it lights up something. Let's add these constants right here. All right. So we have a host, we have a port. Everything else looks good. I think we're ready to try this. Have we missed anything? Socket, host, port. Okay, we're ready. We'll run the server. So Mindstorm is ready for action. Let's get our Doom Eternal up. Well, that's not the one I want. Right here. Okay. Let's definitely get it away from a hit first of all. We're going to start right here where this alien comes out because we know within 8 seconds or so it's going to shoot those missiles at us. We're going to get hit. So we're going to fire it off. Alright, here we go. What is this? Doom feedback. How is that a new Python? Oh, I know what we're doing wrong. We need Anaconda, right? Where's Anaconda? Right here. I think we need to open a new Anaconda window. Is that right? Yeah. cd doom feedback python main.py. Alright, good. So 0, we don't have any red in that image, which is exactly what we should see. Let's go back to this. Let's get ready. Alright, nothing, nothing, nothing. We should hear, ouch, let me hear the speaker close to you. There we go.
Toasty.
There we go. There's a little delay there, but it's doing what it should. Now let's run this again. Whoops. Keep that going. Run the server again. We'll get the server running nonstop in a minute. We should be seeing something over here. Connection refused. Okay. It's alright.
Toasty.
Alright. So anytime we get hit, we are getting the toasty. Let's get this thing to run non-stop now. With socket, I think we just do this while true. We have a socket that's open. I have to really do all this by hand? I guess so. That's already indented. That's already indented. Okay. I don't know if it's going to like these indentions. While true. Let's connect here. Okay, so if not data break, I don't really want to break yet. I'm going to keep in this loop. See if that runs. Whoops. Alright, that might be running full time. Let's go back to this. Good, so we're seeing nothing there. Let's see, there's our red we see. I'm going to... address already in use. Address already in use. So it already, okay, so when it crashed earlier, it kept the port open. So we're just going to bump this by 1. And we'll do the same here. So our port changes to 506. Good. So when I switch back, I think it was in the middle. Yeah, it's going to be in the middle of a hit, so we should get an immediate hit. Address already in use. That's really weird. Why is it 32306? Does anyone have any questions on the HSV, like looking in the region of interest, looking in this region of interest? It's another type of object detection. There's a really good video of HSV color. In fact, I think it's on this guy's GitHub. Let me see. I've got notes here for this. That color picker tool that we used. This color picker that we used is, let's see where that is. README. There we go. This one. I think he's got a good video that shows. Let's see. I think we can do this here. Socrates color picker. Yeah. So here he is with a tennis ball, and he uses the same tool. He wrote this tool, so he uses this tool to isolate everything but yellow. So now his HSV range only picks up yellow things. So now he's able to follow this tennis ball. We could do this with any of our robots that we've been building. We could build something really similar to track a yellow tennis ball, for example. Maybe we're making a tennis playing robot. But one way you could find the object to detect and track would be to use HSV range. So this is just a good example of that. Okay, let's see if we can figure out this address in use. Address in use. Oh, let's try another one. Port 5008. And if I just run this, will it... Let's see if it binds to that host and port. So far, so good. We'll do the same thing then. Okay. Oh, I think I know what's happening, but let's just try it to make sure. I think it's in the loop. It's trying to connect to that port over and over and over. Maybe, maybe not. All right, here we go. I'm going to flip back to this. Let's go over here. And we're getting 0 red pixels in this region of interest. We should have a bunch. Oh, we need to move this window over to the left. There we go. Okay, yeah. I think what's happening, I know what's happening, is we're just getting this loop here. We just need to take out this break here. If not data, we're going to pass else, we're just going to play the sound. That should do it for us. There's a chance we need to change this port. Let's go ahead and change it real quick to 5. What's another one? 509. This one will come to 509. Unexpected indent, of course. So I don't think Lord of Sound is on, but he's just now really getting deep into Python, and this is what we were talking about yesterday, is the indent situation when you first move over is a little tricky. I'm just going to clean this up a little bit. Alright, that should do it. All right, there we go. We should get a hit. Activate all the haptics. There we go. Does it keep going? Activate all the haptics. Let's see if this server keeps running. It's still running. Well, I've got a little work to do to get the server to keep in the loop, but you get a good example. So the next thing we need to build, I need a master builder, some Lego master builder to build something to thump. Has anyone messed with these Mindstorms? I know it comes with a lot of pieces that I haven't explored yet. Is there anything I can use for a thump? Because then we can just attach it to your shirt or your temple, something to give a nice little thump to let you know you've been hit. But that will be a stream, maybe another side stream we can do. But yeah, if you've done any Mindstorm work before and you want to give me some hints on that, I'd love it. All right, any questions on the whole process? So here's what we did from start to finish. Took a video, so any video, you can also do it with your gameplay. I'm not going to play the Doom game now, but if you do play it, you need to define a region of interest. For me, it was 155. It was 155 down, 20 left from my screen, so right around here. Then I took 50 by 50 little square to look for any red in the square. Again, red means that we're hit in most cases. Maybe just electrocute. It's not a bad idea, Goldzulo. I wonder if we take one of these wires that does have electricity running through it. It's going to be a really small charge. You can almost do that, cut them out, and just have the copper leads in there. I like where you're headed with that one, though. That's cool. All right, we looked for region of interest. So I had a problem frame at 1201. Let's just see. Oh, I know, I've got it fixed. So we got a region of interest. We do a mask on it, so we use HSV like we showed you with the tennis ball. I'm just arranging the image to get only red out, so we set these ranges, a high and a low range. We count the number of red pixels we see, if it's above a certain threshold. In this case, we set it to 3,000. Then we know that we have a hit. If we get hit, then we send this haptic signal, and we're just communicating with the Mindstorm over a WebSocket, and we're sending a signal. It fires off the motor and says toasty. All right, so it's really basic. It's actually a really basic principle, but it works really well in a lot of situations. There are some gotchas that you would need to do, so if you happen to move the window over or change the window position, it wouldn't work. In Windows, there is a way to grab the window title with Python. So you could grab the window title. Maybe it's Doom Eternal or it's Destiny or whatever you're playing. You can grab the window title, and then you would at least know where the window was, and it's a relative position to go get the ROI that you need. Looks like Slimer from Ghostbusters. I haven't seen that little alien yet. We could also increase the ROI. We could do a lot more. We could change it. We could look for this. This is showing where you're hit from. One way you could do that is, I've done this before too, where you take an image. So we could take a screenshot of that. I want to pause. There we go. You could take a screenshot of this image right here. You can save it, and that could be a reference image. And then NumPy, which is what we use a lot in a lot of these computer vision tasks. NumPy has a command called isClose. So we could say, I'll show you this. Let me paste this. This is a good one if you want to read more about this. We could read NumPy isClose or NumPy all close. And what it does is it matches the pixels in your reference image to pixels of an ROI on your screen. So we can look and say, oh, I found a region where the pixels are the same or really close. You set a threshold here. These thresholds are tolerance levels. And you can say, okay, I did see this little hit indicator, so I know that you've been hit, and we can do the same thing where we pass the haptic signal to the Mindstorms. So there's a few options. That one would be a little tricky too. I think this one for now is the easiest. Alright, so now we've covered 3 different ways to do object detection. I think eventually we're going to get to the point where we actually create tracking, where we will take the car we've been building, the virtual car, we'll do object detection, and then we will track towards the object. We'll do some lateral control and longitudinal control to angle our car and steer our car and accelerate it towards an object. Trinity says you can make the blades on that fan have 9-volt battery leads, give you a tingle every time you screw up. That's a good idea. Let me see this. So the blades on the fan have 9-volt battery leads. That's a good idea too. This little piece in here, what we need is to, I think there are custom Lego Mindstorms. We could probably get like direct electric output from this instead of having to go through a few things. Trendy, once again, proving he's really good at coming up with ways to hurt me. But I like it. We'll try something like that. Alright, cool. If you have any questions, if you need any advice on how to get started on this, let me know and I can share my code with you. You can reach me on Twitch at JBNunn or Twitter at JBNunn, and then I can share a code with you and you can play around with it. I'd love to see what you build. Another shout out to Ice Cream Codes. Congrats on the baby. Another shout out to W. Giorgio for help with this HSV feature. That's why it's always fun to have to stream with you guys and get some good ideas and feedback from you. All right, Trinity, thanks. Gold Zulu, thanks. Oh, Wolfhound. Hello, Wolfhound Jesse. I didn't see you. Welcome, and thanks Justin for joining and everyone else that joined. Hope you have a great weekend. Stay safe and stay inside as much as you can. We'll see you next time. Bye.